This is 8-3 graphic quadratic functions. So if you remember when you did y equals mx plus b, the b was the y-intercept, the number by itself. So for instance, if it's y equals 2x plus 3, then the 3 is the y-intercept. Okay, for a quadratic formula, or quadratic function, I mean ax squared plus bx plus c equals 0, or equals y, one or the other. This c is our y-intercept, the number that's by itself a constant number, so it doesn't have a variable with it. So for instance, if I have 3x squared plus 5x plus 2 equals 0 or equals y, then this 2 is my y-intercept, the number without a variable. It's really the c position. So the y-intercept is the c in ax squared plus bx plus c. In the last lesson, we found axis of symmetry, which came from x equals negative b over 2a. And we used the vertex. The vertex was negative b over 2a for the x, and then we plugged that in to get the y value. So that's how we came up with the ordered pair x comma y. The x was the axis of symmetry, and the y, we plugged in the x to solve for y. You will use all these characteristics to be able to graph. So just kind of what I summarized here, the axis of symmetry is a formula used to find the value of x, and the formula is x equals negative b over 2a. The vertex is the maximum or minimum point of a parabola. It's an ordered pair, x comma y. So if you're told to graph a quadratic equation like y equals 3x squared minus 6x plus 1, then we're going to need to find all these characteristics. So we start with the axis of symmetry. X equals negative b over 2a. So from that equation, a was 3, b is negative 6, and c is 1. That was the information from the quadratic equation provided. So therefore, x equals negative b, or opposite b, which is going to become positive 6 over 2a, 2 times 3. And that's 6 over 6, which equals 1. So my result for that was x equals 1. Now find the vertex. Well, the vertex is x comma y, but I already have the x, and I'm wondering what the y is. So I have to plug that 1 into the original equation. Y equals 3x squared minus 6x plus 1. So I'm plugging in the 1 into the x. And I need to follow PEMDAS at this point. So I'm going to do the exponent first. So the 1 squared is 1 times 3 is 3. Minus 6 times 1 is 6, plus 1. So y equals negative 3 plus 1, which is negative 2. So I got 1, negative 2. That is my result. 1, negative 2. Find the y-intercept. Remember, the y-intercept is just the c value. So in the equation y equals 3x squared minus 6x plus 1, the y-intercept is right here. So the y-intercept is 1. Let me put all this here so we can see it nicely. All right, and then find 2 more points. So we can pick any 2 points that we want to. So if you want, I could pick, let me see, I got 1, negative 2. Let's do 2 and 3. So I pick 2 and 3. Then I'm going to plug those into the equation. Y equals 3x squared minus 6x plus 1. Y equals 3 times 2 squared minus 6 times 2 plus 1. PEMDAS, we do my exponents first. 2 squared is 4 times 3 is 12, minus 6 times 2 is 12, plus 1. So y equals 1. So 2 comma 1 is one of my ordered pairs. And then my other one, I'm going to plug in the 3. So 3 times 3 squared minus 6 times 3 plus 1. Y equals 3 squared is 9 times 3 is 27, minus 18 plus 1. Y equals 9 plus 1, so y is 10. So 3 comma 10. Okay, I've taken that information and I moved it into Step 5. So my axis of symmetry is x equals 1. So the things I'm going to graph right now, I'm going to graph my vertex 1, negative 2. So let's see what that will look like. 1, negative 2. That's the vertex of my graph. I know that my parabola is going to open up since a was equal to 1. So I know that that vertex is a minimum. And the y-intercept, so the y-intercept is 1. I'm going to place that right there. And then I'm going to graph my two other points, so 2, 1, and 3, 10. Okay, and then step 6 is you can reflect those points across the y-axis. So I can draw a mirror image of this parabola. I'll do that in black. So if I reflect the green points, I have the y-intercept that we already knew. And for the other one, it would be, let's see, I can go up like this. 1, 2, from the vertex, I'm counting up 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and over 2. So I'm going to go 12 and over 2 the other way. So I've created a mirror image from my axis of symmetry. If that helps you, you can draw an axis of symmetry here. But I've reflected that on the other side, and now I have my parabola. Should be like a U-shape graph when I connect the points.